Hello everyone, welcome to our channel Code with Sunny, and in this video we'll be talking about the problem of biweekly contest 94, and we are going to deal for the third problem, minimize the maximum of two arrays. So let me give you the brief insight for this problem. You are having the two arrays, array 1 and array 2, and which are initially empty, and you need to add positive integers to them such that they satisfy all the following conditions. So array 1 contains unique count 1 amount of integers, and it should be distinct, and each of which is not divisible by divisor 1. So you'd be given unique count 1 also, and you'd be given divisor 1 also. Similarly, array 2 contains unique count 2 distinct positive integers, and each of which should not be divisible by divisor 2, and no integer should be present in both array 1 and array 2. You are given a divisor 1, divisor 2, unique count 1 and unique count 2. You have to return the minimum possible maximum sum of integer, like minimum possible maximum integer that can be present in either array. Okay, so let me explain you with the help of some examples, then the problem will be clear to you. So you'd be having some divisor 1, d1 is equal to 2, and you'd be having some count 1 that will denote number of elements that will be present in the array 1. Similarly, we will be having d2, divisor 2, which is going to be 7, and we have count 2, number of elements that is present in the array 2, which is going to be 3. Okay, so we need to find the uh, maximum element that can be present in either array. Okay, remember that we need to minimize the maximum possible element. Okay, we need to minimize the maximum possible element. So let's try to build the array first. Okay, let's try to build the two arrays. We have this one array and we have this two array, like size is going to be 3. Okay, and remember that for each let me write down one more condition. For each element, for each let's say a1, which is going to be, let's say, array a, that is for each ai, like ai should not be ai modulus, let's say it should not be divisible by d1, right? So ai modulus d1 should not be equal to 0, and similarly for each bi modulus d2 should not be equal to 0, and array a and array b are going to be pairwise distinct, like each element should be present like either present in array a and or present in the array b, but like it cannot be present in both the arrays. Okay, so d1 is going to be 2 and d2 is going to be 7. So let's try to fill this d1 array. So if you'll place 1 over here, like the element value is going to be 1, you can see 1 is not divisible by 2. Okay, so it means that 1 can be filled over here. Now we have d2 and 7, so we'll try to fill the elements in such a way that it should not be divisible by 7, and it is not present in the first array as well. So we'll write down 2, 3 and 4. You can see 2, 3 and 4 are not divisible by 7. So here it goes. So you can see the maximum possible element present in both the arrays is going to be 4. Hence our answer is 4. Okay, so you can see our answer is coming out to be 4. Remember that there can be a lot of different ways to have the answers. Like if you are not filling up 2, 3, 4, let's say we are filling up 5, 6 and 8. Okay, so in that case maximum possible answer is coming out to be 8. Okay, but you need to minimize the maximum possible integer. So you need to fill the elements such that elements will be of elements will be such that we have the maximum possible integer will be minimized. Like there are a lot of integers, it can go up to 1 e power 18, like 10 raised to the power 18, or there are infinite amount of integers, but we need to fill the integers in both the arrays such that the maximum possible integer in both the arrays is going to be minimized. And you can see the optimal way to fill the second array is going to be 2, 3, 4. Okay, so how we are going to use an efficient approach to find out this solution for this problem. Remember that we have one more condition. like unique count 1 and unique count 2. That is CNT1, count 1 and count 2 is going to be less than 10 raised to the power 9, less than like it should be greater than or equal to 1. And similarly count 1 plus count 2 is going to be less than or equal to 10 raised to the power 9. Okay. Yeah, here it is too. Now you can see that this value is actually used if it is 10 raised to the power 5, like the total integer is, let's say, 10 raised to the power 5, this count 1 plus count 2, then we will just iterate through the array, and we'll just like iterate up to 10 raised to the power 6 or 10 raised to the power 7 elements, first 10 raised to the power 7 elements of the natural numbers, and then we'll try to fill up the suitable array values for the array 1 and array 2. But this value is actually huge. You can see this value is actually huge, 10 raised to the power 9. So you cannot iterate up to first 10 raised to the power 9 elements of the natural numbers. So you need some efficient algorithm to compute the answers. So let me write down the approach. So approach is very simple. You will use a binary search. So why we are using a binary search approach? Because if for a certain answer, if it satisfies, if we are just able to, let's say our maximum integer is, let's say, 4. Okay, like for the previous example, if you are having, if you are able to complete the array 1 and array 2 and such that the maximum integer is going to be 4, then if for all the integers which are greater than or equal to 4, like 5, 6, 7, 8, 9, 10, then we are also able to complete the array 1 and array 2 as well. So it means that our answer is actually an increasing function, and we all know that for an increasing function as our answer, we can always apply the binary search. Okay, so let's try to find out the optimal approach, optimal check function using binary search. So we are using the binary search. So for a particular value of mid, which is nothing but L plus R by 2. Okay, so we'll try to check whether there are optimal amount of integers such that it can be filled in array 1 and it can be filled in array 2, such that for each element of the array 1, ai should modulus d1 should not be equal to 0, and similarly bi modulus d2 should not be equal to 0, and elements of array a and array b should be pairwise distinct. Okay, so for a particular value of mid, we will try to check if there are sufficient integers such that there is no elements present in the array A which is going to be divided by divisor 1, and no elements present in the array B which is going to be divided by divisor 2, and array A and array B are going to be completely filled. Then we can say this is the optimal value of mid, and we just go to L equal to mid plus 1. Otherwise we go to R equal to mid minus 1. Okay, so now we are at current value of mid. Okay, let's say we are at current value of mid. Okay, and we have this d1 and we have this d2. Okay, now d1 and d2 plays a very important role to find out the answers. Okay, now there are two cases. Okay, let me write down. If d1 is exactly equal to d2. Okay, so if d1 is exactly equal to d2, so let's try to find out those integers. Let me write down a different value. Let's say I'm going to write down count. So count denotes those integers which are not divisible by d1 as well as d2. Okay, so it is nothing but mid minus mid divided by d1. Remember that d1 is actually equal to d2. Okay, so you can see this value is actually the integer division or the floor value mid by d1. So count represent those integers which are not divisible by d1 and d2. Remember that d1 and d2 are actually same. So like if we just do something like this, mid by d1, so let's say mid is 7 and d1 is 2. So 7 by 2 is actually 3. So it means that there are 3 integers, and the integers are something like this: 2, 4, 6, which are actually the multiples of d1. Okay, so if you subtract the multiples of d1 including the d1, then we'll get those integers which are divisible, which are not divisible by d1 and d2. So now if like for this case, how the binary search will be done is like if count, if we have this count is going to be greater than or equal to, we have total amount of integers that we want is count1 plus count2. Okay, so if we have sufficient amount of integers, then we will say r equal to mid minus 1. We'll search for some lower value of mid, else we'll search for l equal to mid plus 1. Like if you look out the code, I've just done two separate cases. If d1 is equal to d2, okay, and we just find out that, and we have checked if count is greater than count1 plus count2, then go to the previous r equal to mid minus 1, else l equal to mid plus 1. Okay, now let's look out for the another case 2. If d1 is not equal to d2, okay, so we will try to find out three separate values. Let's say c1 and c2 as well as common. Okay, so let me write down the definition of c1 and c2. Integers which are divisible by c1 only. I remember that integers which are divisible c1 only, it also means that integers with like which are not divisible by c2 as well. Okay, so only c1, it means that only c1, not c2. Similarly, c2 is going to be like integers which are divisible by c2 only, and it means that c2 only, not c1. Okay, so don't get confused that integers which are divisible c1 only means that multiples of c1. Like suppose you have d1 equal to 2 and d2 equal to 3, then c1 will denotes integers like 2, 4, 8 and 10 and 14. Remember that we must check out for the multiples of 2, then 6 must also come, but we are not taking 6, because if you take 6, then d2 will divide 6. Okay, so we are not having the count of such integers. Okay, so c1 will denote integers which are actually divisible by d1. I think I've written some mistake, so it is over d1 over here, and either here also d1 and here also d2. Similarly d2 d2 as well as d1. Okay, now we have this common, so I'm going to write down integers which are divisible by d1 and d2. Okay, so how do we calculate these values? So let me just try to explain also. So c1 is going to be like something like this: mid divided by d1. Remember that this is going to be integer division, minus mid divided by the integer should not be equal to like integers which should not be divisible by d2 also. So I will just say minus common. Okay, similarly c2 is going to be mid divided by d2 minus common. Okay, now if we have c1 and c2 and we have the common also, now we'll try to make the array 1 and array 2 as well. So we have this array 1 and we have this array 2, a1 and a2. Okay, now we want count 1 amount of integers over here and we want count 2 amount of integers over here. Okay, now we have the c1 integers over here and c2 integers over here. Remember the definition of c1 is integers which are divisible by array 1 like integers which are divisible by d1 only and not d2, and similarly c2 denotes integers which are divisible by d2 only, not d1. Okay, so how do we distribute the elements? Okay, so what we will do, we will try to put the elements that are having of type c2. So we'll put c2 over here and we'll put c1 over here. Okay, so putting elements over here c2 is optimal or not? Okay, so let's try to understand that. So what is the definition of c2? Integers which are divisible by divisible by d2 but not d1. Okay, remember that array A1, according to the definition, you can see each of which should not be divisible by divisor 1. Okay, so we are just putting the elements of type C2 which is divisible by D2 but not D1 into the array 1. So yes, it is correct. Similarly, we are putting the elements in the array 2 of type C1. So what is the definition of C1? Divisible by D1 but not D2. So if you look out for the definition of array 2, it should not contain any element which is divisible by D2. So putting the elements of type C1 is correct also, because C1 contains those integers which are not divisible by D2 but divisible by D1. Okay, now we are done. So we have some elements being filled, some elements being filled. Okay, so let's see the remaining amount of integers that we have is something like this. So we have this count1 should be subtracted by minimum of count1 comma C2. Similarly, count2 will be subtracted by minimum of count2 comma C1, because we are transferring C1 integers to A2. Now we have some amount of leftover integers over here, some amount of leftover integers over, like it may also be like entire array will be occupied, and sometimes also it may also be unoccupied. So what is the remaining integers that we have left? So remaining integers is going to be mid minus C1 minus C2 minus common. Okay, so what is the definition of this remaining integers? Those integers which are not divisible by C1 as well as not divisible by C2, like it is not going to be divisible by C1 as well as C2. Now this amount of remaining integers can be distributed to both the arrays, like it can also be distributed to both the arrays. So our condition is very simple. If count1, which is the remaining integers in the array 1, and count2, which is going to be the remaining integers for the array 2, is going to be less than or equal to remaining, then we will say yeah, we can fully satisfy array 1 and array 2. Then we will say r equal to mid minus 1, otherwise else l equal to mid plus 1. So this is the entire binary search that we need to do. Okay, so let's try to look out for the coding part. Okay, so we'll be having L as 1 and R as 1 e power 15, and we'll be having the maximum answer equal to R. Let's say D1 is going to be having divisor 1 and D2 is having divisor 2, and count 1 is having the unique count 1 and count 2 is having the unique count 2. And one more thing, I think whether I have written the common, I think I haven't told you the definition of common. So common is something like this, like mid divided by LCM of D1 and D2. So because it is going to be divisible by both D1 and D2, so we would be also requiring LCM. So we are just having product of the numbers divided by their highest common factor. So we will do the binary search, L less than or equal to R. We'll compute the mid. So if D1 is D2, so we'll just find out those integers which can be taken such that it can be filled in both the arrays. So if that count is going to be greater than or equal to the required count, count 1 plus count 2, then we'll just go to the smaller value of mid, that is r equal to mid minus 1, and we'll just store the answer as well, answer equal to mid, and else l equal to mid plus 1. Similarly, we'll just check out for C1 and C2 also. C1 contains integers which are divisible by D1 only, not D2. Okay, and similarly C2 contains integers which are divisible by D2 only, and not D1. Okay, so let me write down over here D1. Okay, now let's say the common integers are made by LCM, and we have this C1 which is going to be the integers which are divisible by D1, and we have to remove the common part also, and similarly C2 also. Now let's say Z1 and Z2 will denote the integers which should be filled in the array 1 and array 2 also, and we have this available as the integers that can be filled in either of the arrays. Okay, for the corresponding value of mid we have the certain amount of integers. Okay, so first of all we will try to decrease the Z1. Z1 is going to be for the array 1, so array 1 can take C2 integers. Okay, so we'll just decrement Z1 as minimum of Z1 comma C2, and similarly we'll try to decrement Z2 also. So array2 can take C1 integers, and we'll just say if Z1 plus Z2 is less than or equal to available, we'll say yeah, we can just try to look out for the smaller value of mid, that is r equal to mid minus 1. Otherwise you will look out for the greater value of mid. Okay, so this code will give you all test cases passed. So if you have any doubts, you can reach out to me through the comment section of the video, and thank you for watching this video.